we can start tinkering with coffee shop stuff again. All right.
All right.
So let's open up Ubuntu. There we go. CD /A. All right. So, should we go straight into doing coffee shop stuff, or should we tinker a little bit with Linux first?
What? Sorry, what would you tinker with Linux with? Like, to what end, I guess?
Yeah, there's just some preferentials that I have as far as interacting with Linux on the command line, but since that's not really the point per se, let's just go straight into coffee shop stuff. So CD for change directory, coffee shop, boom, and then we'll go code dot,
All right.
and that will open up VS Code, which looks like we still had it open. I'll go ahead and close that out just to open it back up from the way it would if you were, like if you rebooted your laptop or something. So that pulls up the file that we were working with, the output panel, and then we will say start up a REPL and connect to it in the background. So REPL, yeah, let's open up a new window here. All right, so REPL, R-E-P-L. What is that? Read, evaluate, print, loop.
So it is a thing that does all those things.
Yes. So a REPL, the languages that I know of that use a REPL and use the term REPL are Haskell and Clojure. I'm sure there are others. These are the two that I know of. So a REPL takes, you've got your terminal, right?
Right.
And running within your terminal is an interpreter that when you type something in, like +1 and 1, it takes that, that's not what I wanted to happen. Interprets it according to the rules of whatever language you're working with, and then brings back the result and prints it. So that's where your read, take it, evaluate it, use the rules of this language to figure out what it should be. Print, that's give me back the result of what I just did. And then loop, wait again for another thing to read.
Right.
So if I go over here and I say line REPL, then this is what we did to start off with last time when we were checking to make sure that everything was working correctly.
Okay.
So this is a REPL, and it's sitting here waiting for me to type something into it. It'll evaluate it, it'll give me back the answer, and then it'll wait again. That's a REPL.
Okay. So not all programming languages do that?
Not all of them, no. So some programming languages, instead of having a really quick feedback loop where you can type something in directly, it'll go run it and then come back and give you the result. Instead, you have something that is a fully compiled language where you type up what the instructions in this program that you want. You save it. You feed that into a compiler. The compiler returns back a packaged up program if it didn't run into any errors. and then you try to run that program. So the effect is very similar, but it's much slower. So
Gotcha.
basically having a REPL means that you can try stuff out live and just
Okay.
immediately get feedback from it.
So I've done stuff like that. Oh, sorry.
No, go ahead.
I've done stuff like that with Python on a
Mm-hmm.
terminal, and I just press 1+1, didn't even press anything like
Yeah.
print, and then it returns it. So Python also uses a REPL.
I am not sure they call it a REPL. So if I quit this and then say Python 3, so this is an interactive thing, but it's in Python. So do I even remember how to do Python stuff? X equals 1 plus 1. Give me back X, and it's 2. Or if I just say 1 plus 1. Yeah, so this is basically doing the same thing, but I don't know if they call it a REPL.
Okay.
And I'm not sure what the technical differences there would be. But yes, it's similar. So if I say quit, oh, it has to be a function. So what's happening over here? What's happening over here is this extension that we installed yesterday, which is called Calva, has an integrated REPL. See, right there?
Ooh.
Integrated REPL. What does that mean? That means that down here in the terminal window, this says in REPL is running, and it's connected up on this channel, basically. This is an IP address with a port on it. So in REPL server started on port 43737 on host IP this. That means that even though I don't have a window in front of me that I can actually like type into in order to interact with this REPL, that REPL is running in the background and it's waiting for input. And VS Code knows how to send something that's in my text file. Like this is a file of text that is saved within Ubuntu. If I go over here and I go into the source directory and I say cat out core. CD. So if I cat out core.clj, this is the text that's saved in that file.
Okay.
And it's exactly the same as what's over here. It just doesn't have the syntax color coding. So this is actually a text file. But because I'm running this extension for VS Code, if I type something, a valid Clojure form over here, let me make this a little bigger for you. If I type a valid Clojure form over here and then hit evaluate, Calva takes whatever's within, you can see a little bit of highlighting there.
Right.
It'll take whatever is within those parentheses and send it to that REPL that's running in the background. And it does that read, evaluate, print loop, but without me directly interacting with the REPL. It's running that from VS Code. So that means I get all the benefits of both being able to interact immediately with an interpreter of the language, and it'll tell me if I got something wrong. Like if I say add together the letter A and the number 1, it'll come back and say, nope, you can't do that. Well, why not? And then I can try and figure out what this execution error means. Let's see. Cast exception. Casting is the term for when you're trying to turn a value of one type into a value of another type.
Okay.
So casting, class cast exception. Can't do it. What? Class Java language character. This is a character type. Cannot be cast into the class of Java language number. I don't know. This is the language talking to me. I don't know how to turn a character into something that can be added to something. What does it mean to say plus A? That doesn't make any sense. So it's given me back this error, and if I have figured out how to read it and I know what it's saying, then I can go, oh, that's a mistake I made. Let me give this an actual number, and then it'll be able to run it and evaluate it.
So it um can't use variables in Clojure then?
You can use variables, yes, but so if I say def, which is the Clojure function, everything in Clojure is a function. So in some languages like Python, you have special keywords like if and then. Are if isn't a variable in Python; it's a keyword. Like it's a control flow keyword. It's a special use of this word to mean this thing. In
Right.
Clojure, everything's a function. What does a function mean? A function means that you have something, banana, and that something goes in one side of something, this, and it comes out the other side, we'll
Something
say
else.
B. This is a function.
Yeah.
So everything in Clojure is a function.
Yeah,
So
because I was even seeing you instead of putting uh like expressing addition how you would mathematically, you're putting plus first because I assume
right,
that's a function too.
yep.
And then those are the two variables you're adding to that function.
I would say the two values that I'm adding.
Values, yeah,
Yeah,
sorry.
a variable is a named something. So the def function in Clojure assigns a symbol. Symbol is the name for anything that references something else. So if I say def a value, this that's underlined in blue right here is a symbol. And I'm about
Okay.
to tell Clojure what that symbol means. 7. Okay, now def says, oh, in the future, if I see a value, I'm going to give it a 7. But not until I evaluate it. Boom. Now I've evaluated it, which means that Calva has sent this piece of code over to the REPL. The REPL has now learned that a value means 7. And now if I use a value down here, Clojure, when it sees a symbol, will try to get whatever that symbol is referring to. So now you can see here it has worked. If I have plus 3 and a value, and I get back 10, that means that it has successfully gone and gotten 7 as the value.
Okay.
So
So,
that's more how variables work in Clojure.
and how would that work if you didn't have Calva as an add-on?
Mm-hmm.
Like would you need like is it necessary to have a REPL and you just get it from anywhere, or is there some way that you can define a variable or a symbol without a REPL?
There is. So if I was, let's see, Notepad, you don't need anything fancy to start writing Clojure code, right? So the top of a Clojure file always has a namespace. So we'll say namespace. I'll just copy what I've got over here. Coffeeshop.core. This is a keyword that says when I compile this, I want you to turn it into a Java class. And then I have the require, and I think I required spec up here. Yep. Clojure.spec.alpha as s plus 1 1. Boom. Save this somewhere on my computer, and then point the Clojure's compiler at that text file, and it will spit out a compiled, um, probably a
Okay.
Java program.
So you're just doing the thing that you would do with other programming languages you just talked about.
Mm-hmm.
And instead of just having it happen, you kind of have to do it manually and like run it through a
Right.
compiler.
Yep.
Okay.
So like if you were
But
writing C or C++, you would be, well, I mean, you would have an development environment like this one set up to speed things along even then. But the feedback loop for try something, see if it worked. Oh, it didn't. I need to adjust something is recompile. And your compiler will give you an error message or a warning or something if you've got something wrong.
hmm,
So Clojure has a REPL which just speeds up the feedback loop. and it's more
Gotcha.
interactive. So the way, even if you're trying to figure out, well, how do I do this? I'm not really sure what I'm doing. You can kind of you can people describe it as talking to the REPL. You're almost having a conversation in order to figure out, is this valid? Does this give me back what I was expecting to get, or does this throw an error and then I realize I got something wrong? So it's just
Hmm.
it's a quicker way of iterating, because
Gotcha.
with Calva, by the way, I'm hitting Alt and Enter over here in order to say go check this against the REPL and give me back whatever it gave you.
Right.
It's not running the entire file when I do that. It's only running the one um, expression
Highlighted bit.
that I'm working in at the moment. So it's just a quick way of figuring out, does this do what I thought it would do?
Gotcha. Okay.
So if I
Uh,
if I delete these, if I delete this where it defines what a value is, boom, I've deleted it. And now I come
now it's
back
going to
down here and I try
hold
to
on.
run this. What do you think is going to happen?
It's going to say, well, you've already fed in the bit
Uh huh.
into the REPL,
Uh
and
huh.
it's a separate thing.
Yeah.
So
It
because you've
still
already
works
fed that in,
just fine.
oh,
Yeah.
okay.
But if I was to save this file, close everything down, and come back up and open it up again, or I've got this REPL that's running down here in the bottom corner. If I disconnect from the REPL and then reconnect again, it has now forgotten what a value is supposed to be because I deleted that definition in the file. That makes
So it's
sense?
more of a RAM thing than it is a full-on storage bit.
Yes, yes. And the ordinary programming term for what you just described as RAM is state.
Hmm.
So the REPL has certain things loaded, and it has certain things that it has evaluated that are now accessible. That is the current state of the program. And for the
Okay.
most part, in functional languages like Clojure and Haskell, you try to avoid relying on state as much as you possibly can. It's not, once you start to interact with the real world, there's always going to be some state somewhere, but you
Mm-hmm.
try to structure your program in such a way that you're not taking anything for granted. And that tends to make things more repeatable and more reliable. You avoid some of the problems that some other languages run into, and they've come up with ways of managing the state in a C++ program or in a Go program, or whatever you may have. But
Mm-hmm.
this style of programming where you depend on state as little as you possibly can is an approach to programming that's called the functional way of programming. And that's what Clojure uses, that's what Haskell uses, and that's what
Gotcha.
I have the most experience with. Okay, so that's just talking about programs and programming in general. Let's think a little bit about how we're doing our virtual simulated coffee shop, and then we can talk about some other stuff or do something else if we want. So
Cool.
far, all we have done is give a definition for what a latte looks like.
Mm-hmm.
And we built that definition up using smaller definitions of other things.
Right.
So what else might our coffee shop need? Let's think about it. So before there's we can go bottom up and we can start fleshing out a bunch of small details about how things are defined, or we can kind of go top down and say, how is this whole thing going to work together once it's done? So we did a little bit of the bottom end side of things. I'm gonna do a little bit from the top for a bit. So
Okay.
what is actually the way this program is going to function? Like what's this program going to do? I would like, it's a simulation, but I also am starting to think of it kind of like a simulation game. Like um, there's a challenge, a little bit of challenge to it, and you're trying to succeed in playing
Mm-hmm.
this game. So the player of the game is going to have some kind of input into the simulation.
Mm.
Then the simulation is going to run, and there might be other inputs like environment stuff that's going to be consistent, or let's see, details. And I would imagine this being stuff like we're going to simulate running a coffee shop in a specific city. So Seattle is going to be different from New York in some way. So the player gets to have some kind of input, and this is going to be fun stuff, not the nitty-gritty things. So like, how do you want to manage your coffee shop? How many people are you going to hire? And like how what decisions are you going to make about your like business strategy? So like marketing, you're gonna decide, well, I want to have a budget that I give to marketing my thing, and then like quality of ingredients kind of stuff.
Maybe like brands of different things you import, or like where you're getting your milk,
Right. Yeah.
where you're getting your coffee.
Yep. So like maybe part of it is like plantations that actually produce the coffee beans kind of thing.
Maybe.
But then this simulation, how is this going to work? So it seems to me that when I'm running the simulation, it's running over time. So there's like, we'll start doing it a day at a time, I think. So for each day, we'll start off very simple. Each coffee shop makes coffee. And then we get another day. So let's start with, if I tell the simulation how many days I want it to run for, then it will run, let's say if I say, okay, go for 5 days, then it will give me back, okay, here's what happened in those 5 days, basically.
Okay.
So how do I do that? Well, I'm going to have a function, and in order to run a function, or in order to declare a function, I'm going to say def in. Then I name the function. I'll call this run day. Well, let's call a function coffee shop. That's going to take in some arguments, and then it's going to do some stuff. And then I'll have another function, def in run day, and that will actually do for each day. So I'll tell coffee shop, let's spell this correctly. I will tell coffee shop I want you to run for 5 days, or however many days. So then if I want, so let's say I give coffee shop the number 5. I now want it to go do something 5 times, right?
Right.
So then I'll say, the way I would do this in Clojure is to say loop, and then within the loop I say what I want you to do something with in this loop. So what day are we on? And I'll get that straight from days. This will make sense in a second. And then history. This is where I will, for each time we do this loop around, it's going to save some information about what happened in that day, right?
Okay.
So I will start from a sorted map, and that's just empty for history. But then each day I go through this, I'll inject something into that map and then run it again with like passing the ball from each day to the next day and adding a new item to the end of it. Right? Does that make sense?
Yeah.
So Next, I need to figure out, okay, when do I exit the loop? Because otherwise this loop would be infinite. So if, and what am I gonna use for this if? Well, if I've got the 5 up here, and then I do the loop, then I want to have a 4 over here, right? And then I'll do the loop again. And then 3, and then 2, and then 1.
So in Python, I think like this is just a for loop is what it would be called. So for this many elements.
In Python, this would be a for loop. Yep. So for this one, I'm going to say if, well, let's see, if day, if, and because it's Clojure, I have to put the operator up at the front like this, because that's how you run a function. Right. If day is equal to 0, right? Because if it's equal to 5, do the loop. If it's equal to 4, do the loop. If it's equal to 3, do the loop. If it's equal to 2, do it. If it's equal to 1, do it. And that would be 1, 2, 3, 4, 5 of them. But if it's equal to 0, then end. Right? So if day is equal to 0, then what do I give? What's the output of the function at that point? It's the history. Whatever the history is up till this point, give that back. Otherwise, I want to add something into the history and then do it again. So in order to do that, I say recur. And then I tell it, okay, what values am I going to recur with? And it will always match back up to these 2 items, day and history. I've already decided for this loop, the 2 pieces of information that I'm going to do over and over again are day and history. So down here, I'm going to say minus day and 1. So the next time you do it, take that day down by a step. And then in history, I'm going to associate or assoc. That's the function for adding something into a map. So I've got this sorted map up here. I'm going to assoc with whatever day I'm on right now. So if I start this with 5, and we start running through here, then this is going to be 5. And then this is going to be 5. Which means that this is going to be 5. Which means that this is going to be 5. 5 is not equal to 0, so it will not go exit the loop. It will go into a recur. It'll set this to 4 for the next time I go through, and it will set assoc a day, and for now, just to keep it simple, I'm going to say coffees 100. Just to see if this works.
Sure.
Yeah.
All right.
Yes, please. All right, so let's try and evaluate this function. And if it's a valid function that works, what is this? What is this reminding me of? Recur argument count mismatch expected 2 got 1. Okay. Well, what does recur expect? Oh, okay. I did this incorrectly. I don't actually want this vector thing going on here, but that's okay. I can get rid of that. Let's see.
Okay.
There we go. And then this is saying there's a problem here. Assoc is called with 2 arguments but expects 3. That makes sense. So this function, the point of this function is to add 2 things into a map, but I have to tell it what map I'm actually doing. There we go. That should work. Coffees 100. Okay, I don't see any more red squigglies, so hopefully we're good. Let's try evaluating it. Okay, that evaluated as this is a function. Okay, cool. So let's try calling that function. So coffee shop 4. Or no, let's just stick with 5. Boom. Hey, look, we get back a map that says on day 1, you made 100 coffees. And then on day 2, you made 100 coffees. And then on day 3, you made 100 coffees. And then 4, you did 100 coffees. And then on day 5, you did 100 coffees. That's perfect. So if I run this with 7, then I would get back a history that says on day 1, on day 2, on day 3. So if I do 4, boom.
Well, that's 2.
Well, yeah, if I do 2, then on day 1, you did 100 coffees. On day 2, you did 100 coffees.
So we're getting an, would it be output or throughput of 100 coffees a day?
I think...
Probably,
I don't
it
know.
doesn't matter.
Yeah. So in the future, instead of just hard coding, giving me back 100 coffees a day, I would replace this with probably a function call that says run the coffee shop for a day, right?
Mm-hmm.
And then this could have other functions in it that say, well, figure out how many customers you got today, and then figure out how many of those customers you made happy, and blah, blah, blah. And we could have
And that
other
that would
things.
probably be part of the environment end that you were
Mm-hmm.
talking about.
Mm-hmm. But now I've got, this is like the core loop of here's a coffee shop. I give it a number of days and it returns, here is what I did for all those days. So then now let's say arg, instead of interacting with my coffee shop simulation inside of this editor environment, because this is great for me, I'm a developer, but if I ever want to like release this game to somebody else, they're going to want to be able to download it and play it, right?
Yeah.
So then how would I make this interactive to the rest of the world? That's what this dash main thing does. So let's leave this like that, save it, and then go to, this is back in Linux. I'm in my coffee shop project. If I say lean run, then it will pull together all of the details and information in my Clojure project and then try to execute whatever it is. So right now, this is telling this dash main function is the entry point for the whole program. Whenever the program starts, it tries to execute this main function. So right now, the only function in the main function is print hello world. And if we come over here, that's exactly what it did.
Right.
So instead of doing that, what I want to do is say, okay, if I give you main function, if I give you a number of days into dash main, I want to get back something like this over here, right?
All right.
That's what I want to happen. I'll give you a number and you give me back a history of what happened in those 4 days. So in order to do that, I would say print the result of executing the coffee shop function given some input. What input is that going to be? Well, that's going to be the input that I put into the command line. So over here, when I say lean run 4, I want it to grab that input and take it into the program and do something with it. So I'll say arg. In Clojure, if you have an ampersand and then something after that, it'll be just also bring along all the rest of them if you get more of them. So I could actually do lean run 4, 5, 6, 7. That doesn't matter. If I say arg and args, then this will be understood as the arg, and these will all be together understood as the rest of the args. So if I don't do anything with them, it's fine. It doesn't break anything. It would just grab the first one and try to do something with it. So
all right.
What happens if I say, okay, my main function is expect some input and name whatever the first input is arg, and then feed that arg into the coffee shop program? What do you reckon would happen?
It sounds like if you put in 4, it's going to run through 4 days, each time adding 100 coffees. And so what we should see in the main console is what the output on the right side was,
Mm-hmm.
which is just day 1, 100 coffees, day 2, and it gives you a readout of all of
Mm-hmm.
them.
That is what we would expect, except that when I actually try to run this 4 comes through as the character 4. It doesn't know that this is a number.
Oh,
Yeah. So if we go ahead and that compiled just fine. If I come back over here, if I save it, and then I try to run with 4,
nothing happened.
I don't think anything happens. I think it gets, yeah. Oh, see,
Oh,
we got this issue. This didn't work. Something happened. So this really long, nasty looking error message is
yeah.
that happens because Clojure, the programming language, runs on top of Java. Java is a whole self-contained world called the Java Virtual Machine, or JVM. So the Java Virtual Machine has a whole bunch of stuff in it for handling everything that could possibly happen. And that means that people who are way more involved and have way more complicated things to do with programming than I am would still be covered. I'm trying to do something super, super, super simple. But because Java is equipped to handle all kinds of nonsense that I don't even know about, it's got layers that it goes into. So basically, when I give Clojure something and say, here, go do this, it gives it to Java, and Java gives it to something that gives it to something that gives it to something that gives it to something, all within Java. And each one of these lines is that thing coming
one
back.
Of those layers.
If I gave it something that worked and it went through all the layers and then came all the way back, we would have no problem. But because I asked Clojure to go do something, and Clojure asked Java to go do something, and Java started talking to all of its internal components, whichever one of those internal components ran into a problem, it gives a problem message back to the thing that called it, which gives it back to a thing that called it, which gives it back to a thing that called it. And each one of those things is one of these lines.
So that means that the problem runs deep.
Yes.
Like it got pretty far along. And then it went, oh, there's a problem all the way down here.
Yep.
Let's back up.
So this would be really handy if I was fighting something that's just ridiculously obscure and complicated. I could go down and figure out exactly where and why this happened. But fortunately, I'm trying to do something very, very simple. So I can just look all the way at the bottom of this that says caused by. I can ignore this whole list of things. I don't need to learn all that. What does this say? Caused by runtime exception, can't take the value of a macro, Clojure core, analyzing a symbol, exception. So something that went into this wasn't what it was supposed to be. That's basically what this is saying.
So,
and by tinkering around with it, yeah, how do I fix it? That's the question. So there is a safe way to fix this, and there's a hacky way to fix this, and I'm going to do the hacky way, which is when I take in this argument, I'm going to say, okay, if somebody comes in here and they type lean run yo mama, that's just going to fail. It's not going to work, right? They didn't use my program correctly. What my program expects is to get a number that comes into it. If I was going to be more careful and more thorough, I would put something in here that would catch it, even if no matter what they put in there. But I'm just going to assume I'm just doing this for testing. I know how to do this. So I'm going to convert this arg, whatever it is, into a number. Like so.
All right.
So now, if I save this, come back over here, and say lean run for 4, it should.
And this is the nerve-wracking part.
Oh, that didn't work either. What happened? Print line, coffee shop. Can't take a value of the macro. It looks like it's the same thing that happened before.
Could it be because you didn't do the REPL bit?
Oh, I wonder if it's because I left this in here.
Oh,
and
maybe
the full program doesn't actually know what to do with that. I was just using that as an example. What I should be more careful to do is if I'm gonna do like illustrations like this, go ahead and comment those out so that it knows to ignore that. I should be more careful that if I'm going to do an illustration right in the file, that I don't leave something that's going to trip the compiler up. So well actually, if that's the issue that it was running into before, let's try again without just out of curiosity, without doing that conversion correctly. I'm just curious about what would happen. Yep, so this ran into string cannot be cast to class number. That's more what I was expecting. So earlier, when it ran into an issue, it was because I had something in the file that wasn't supposed to be there. Now it's saying, I'm confused. I don't know how to turn a string into a number. So now we come over here and say integer dot and swap that, save that, try this again. Ha ba ba.
Woo! Yeah, baby.
Yeah, baby. So then in the future, right now I just have it spitting out this data record, basically. In the future, there are ways that I can plug that into like a charting program. So then instead of the full thing that's not very readable, what I'll have it actually spit out over here is a chart that says on day 1 and on day 2 and on day 3.
All these things happen.
Yeah. Like you made this many coffees, and on day 2 maybe you made this many, and on day 3 maybe you made this many. So
who are you talking to?
Seth.
Hello, Seth.
Hello.
So maybe that's what I'll do in the future.
Can you hear me?
Yes, he can.
Allie says that she wants to play a game with you again sometime, by the way.
That sounds fun. I'll do it.
But that's all I figured we'd tinker with today, is actually having a way for the program as a whole to be interacted with from something else. And right now I'm interacting with it using this lean command in Linux, but maybe in the future I could have it set up to where you open up a browser window.
Okay.
And you connect it to the coffee shop, and then it pops up and it's got a visual and it's got some sliders on it, and you can say, I'm going to input hire this many people and pay them this much per hour, and I'm going to say buy beans at this rate and advertise to this kind of customer in this city. Okay. And you put in all your inputs, and then it goes crunching, and then it spits back out, here's how well you did over the course of this year or whatever. And that's the game.
Okay, so with that, two questions. One, I was under the assumption, I suppose, that all web pages use HTML to like collect information. So if that's on a website, then you're trying to do something with Clojure. Like that is not HTML. So what kind of happens there?
Yeah. So there's this interesting thing that you don't learn about if you're just using the internet for a long time. And that is, you can have websites that run just on your local computer. So like it doesn't have to go all the way out to the internet in order to get stuff. You've got a program on your computer, and then your browser can interact with that program all within just your computer. So there are libraries for Clojure that let you turn stuff into HTML or respond to HTML requests, because that's what your browser is actually doing. When you type in an address or an IP address, your browser is sending an HTTP request to an endpoint that says, hi, I exist, please give me what it is that you have to give. And then it will send back, here's what you need. And then your browser knows how to take that package of information and turn it into a web page that you can actually see.
Right.
all of that can happen locally on your computer. So you can have a browser tab that's open, but it's not connected to a website out in the universe somewhere. It's connected to a website that's on your computer that's interacting with a program that you made. It sends a request to that program and says, hi, hello, and your program says back, yes, here you go, and then it renders it in your browser, but you're using your browser to interact with a program that's running on your computer. So
Gotcha.
that is what I will be trying to figure out how to do, because I'm not I haven't done this before. That's what I'm going to try and figure out how to do in order to have this coffee shop interactable.
Cool. Okay, so nice. Second question was more of a debugging kind of thing. With the program you already have, it takes whatever argument you put in and converts it to an integer. So if you run coffee shop and then put in a letter instead of a traditional number, what happens?
Right now it blows up. Which blow up just means it doesn't work. So if I have, I've got my coffee shop function right here. If I try to run coffee shop with a letter, this is putting a backslash in front of it is the Clojure way of representing this is just a single letter. If I do it like this, then it would be a list of letters, which is the same thing as a string. So if I try to run this, I get an execution error. I don't know, it says, how to turn a string into a number. Can't do it, don't know how, so it just fails. And it comes back and says, nope, you couldn't do it. So that's all I meant by blow up. And that's the same if you give it a, bless you. That's the same if you give it just a character. It'll say, you gave me a character, and I don't know how to turn that character into a number. Or if I give it a keyword, like right there, it'll say, I don't know how to turn a keyword into a number. Or if I give it a symbol, like a new value, but I haven't set what the value of this value is yet. It'll say, I tried to figure out what that symbol means, because you gave me a symbol and I know how to recognize a symbol, but that symbol's not attached to anything, so it didn't work. Okay. Yep. So that's the same thing that would happen down here, because remember, this is like the bridge for interacting with this program from outside. It's from the outside world. Yeah. So if I do that same thing where I say lean run with a string hi, it'll come back and give me another one of these errors that says, nope, can't do it. You gave me a string. I don't know how to turn that string into a number. Couldn't figure out how to do what you wanted me to, and it exits without succeeding.
Okay. So, but then you said that in the main window, you have all the numbers are felt, I guess, as characters. And then you need to convert that into an actual integer for you to be able to use that.
Yep.
So wouldn't any character technically work with that?
So,
or are there differences?
That's a good question. So right here, if I just write coffee shop and I give it some letters, hi, it's trying to grab these letters and stick them straight into this function. So then it says, okay, day is going to equal hi. If day, which right now is equal to hi, equals 0, and it goes, I don't know how to do that. I don't know how to compare a string of letters to a number. What are you even trying to get me to do? I can't figure this out. I'm going to quit.
Gotcha.
If I put it in over here, where I'm just in a Linux environment and I'm trying to run the completed program as a whole, if I give it hi, it doesn't get this far. It only gets as far as this right here. This is the function that's supposed to turn a string into a number. And if it's able to do that, if it understands how to convert whatever it is that I gave it into a number, then that function will succeed. If it doesn't know how to do that, then it will fail.
Gotcha. Okay. Because in my mind, I assumed it would be something like every character has a number assigned to it, kind of like how you'd have the alphabet. It's a numbered alphabet. The fourth one would be D, or something like that.
Right.
So I figured what was going to happen is that you put in like H, and then it goes, okay, how far down this repertoire of characters is H numbered? And then it goes
Right.
down to that.
That can happen. Yep. So every character has a Unicode value, and it has there are ways of turning characters into numbers that don't necessarily correspond to any kind of number that you intended. So in that case, if you were using that function to convert characters into numbers, then you would get a very surprising result out of your coffee shop simulation, because you would give it like Z and it would run for 1,000,000 years, or however that number that's associated with that character would actually get turned into a number that the function would try to run on. That can happen. Yep.
Okay. And then I guess final question.
Mm-hmm.
Are you seeing any tearing on my webcam?
I am. Yep.
And I'm wondering if that is my webcam or if there's something on Brave that's doing that.
Hard
So
to
now
say.
I'm gonna be checking that out. Yeah, that was cool. I like that. I like learning about this. It's
Cool.
Neat.
Well, let's keep doing it. Like, I have been like thinking about this in the background when I should be doing other things, because I'm just entertained and kind of having fun. And building it up a piece at a time means that we don't have to figure out the whole complexity of all of it and how it would work. We can just say, okay, today, what are we going to try and do? Well, customers. How are we going to represent a customer or whatever? And we can just kind of brainstorm, workshop it, try and come up with something that works, and see if we can make it do the thing.
And maybe after a couple of years of keeping at it, we'll have a game. And
We
then
might. Who knows?
We'll sell it.
All right, bud. I'll let you go.
It was a good time.
Yep.
Love you.